Question 12. Which list contains only properties of an object that can be changed by force? As we know, or as we can notice here, mass is common between A, B, and C. That's why if we need to eliminate options, of course we'll be eliminating these. We'll cancel these options. Why? Because mass is not able to be changed. So obviously the only correct answer is C. Force is able to change direction of motion, shape by squeezing or applying force on an object will be changing the shape and of course the speed, either by speeding up or slowing down. Going to question 14. The engine of a car produces a driving force of 5,000 Newton on the car. Resistive force R also acts. So as it's drawn here, this is the forward force and this is the resistive force. This is the mass of the car, and also we have information about acceleration. We need to find R. We can solve this question by using one step or two steps. So in a very simple way, we need to find R. To find R, which is the resistive force, we need to find the net force, or what is the total, the resultant force in this situation. That's number one, to find the net force. And to calculate net force, we have to use Newton's second law, which is mass times acceleration. Straightforward. Our mass is 800. Acceleration is 1. So obviously total net force is 800 Newton. This step number one. Step two, we know since we have two forces are acting on the same object but they are in two different directions, so we subtract force 1 minus force 2. Force 1 is 5,000 Newton minus R, which we don't know, but we already calculated net force, which is 800. So in a very simple way, this net force will be replaced by its magnitude, which is 800, by using simple math or by using a calculator. This will be converted to the other side as negative. So 800 minus 5,000 will be equal to negative R, which will be equal to, in this case, just use calculator. Of course our answer will be with negative, so it gives negative 4,200 Newton. This is equal to negative R. In a very simple way, negative will be cancelled with negative, so the correct option is B. Next, a box of mass 2 kilograms is pulled across a horizontal floor of force of, so we have information about mass. Let me clear just, we know it's written information about mass, about force. The friction force is acting on the boxes 1. So what is the acceleration? Obviously we have two forces, obviously these two forces in two opposite directions. How can we know? Since we find friction force automatically without even mentioning directions, and here no direction is mentioned. They didn't mention that this force is forward, the other force is backward. No, but obviously here, since we have word friction force, we know that it's always opposite to direction of the other force. So obviously we'll subtract 6 minus 1, it gets 5 Newton. So this is our net force, it's 5 Newton. And acceleration is wanted here by using Newton's second law, force M times A. We can just rearrange it in this way, force MA. This is division, multiplication. If acceleration is required to be calculated, is gonna be force, net force over mass. We just calculated net force is 5. What is the mass? 2. so it gives 2.5, which our measuring unit is meter per second squared because we're calculating acceleration. Option B. Next, going to question 4. In this question, a figure shows a tanker lorry full of liquid. The tanker delivers the liquid and drives away empty. The empty tanker has a weight of, so just a quick reminder, what is weight? Weight is gravitational force, which can be calculated by m times g. What is g? It's acceleration due to gravity, which is equal to 10 meter per second squared, always on Earth's surface. So once we have, this is our weight, easy to calculate mass. Our weight, which is 50,000 over g, which is 10, it gives mass. So 5,000 kilogram. Now, what the question asks here about, the forward force is 6,000 and the total resistive force. So step number 2, we need to calculate net force. What is the net force? Since we have two forces and they are in two opposite directions, we're going to subtract them. 6,000 minus 2,000, it gives 4,000 Newton. That's step number 2. So step 1, you calculate mass. Step 2, you calculate force. Step 3, you calculate acceleration by using the formula of Newton's second law. Net force over mass, net force over mass, net force is 4,000 over mass 5,000. It gives over 5,000 0.8 meter per second squared.